numbers for a while, we're going to look at how to graph a complex number on a plane. Plane is very similar to the coordinate plane that we've been working with. However, on the complex plane, the horizontal axis is your real part of your complex number, and then the vertical axis is the imaginary part of your complex number. So when you're graphing your complex number, you're going to graph the real part on the horizontal axis, and then the imaginary part is graphed on the vertical axis. We want to graph the complex number 2 plus 3i. So the real part is 2. So I mean we're going to go horizontally 2. And your imaginary part is 3, which means we're going to go vertically 3, putting our complex number right here. So our real part is -4, which means we'll go to the left 4 on the horizontal axis. And our imaginary part is 2, which means we'll go up 2, leaving our complex number right here. -3 minus 2i. Our real part is -3, so we'll go to the left 3, and then we'll go down 2 for our imaginary part, leaving our complex number right here. 5 minus I, so our real part is 5, which means we'll go to the right 5 times, and then our imaginary part is -1, so we'll go down 1, leaving our complex number to be right here on the complex graph. 4i will go to the right 3 and up 4, and our complex number will be here on the complex plane. So our question is, if we have our complex number 3 plus 4i, we know that it is right here on the complex plane. But what if we want to know how far away is it from 0? Well, if we look and we remember our geometry, our complex number is making a right triangle with 0, with the origin. So here's a right triangle, and the distance between the origin and our complex numbers happens to be the hypotenuse of a right triangle. Now, if you remember anything about right triangles, you'll remember the Pythagorean theorem. So here, this leg of our right triangle is 3, this leg of our right triangle is 4, and then the hypotenuse of the right triangle will tell us how far our complex number is from 0, or the origin. So Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse of the right triangle. So we said that the legs were 3 and 4, and that c was the distance between 0 and our complex number. So 3 squared is 9, and 4 squared is 16. So 9 plus 16 squared is going to be equal to our distance squared. So 9 plus 16 is 25. So 25 is equal to our distance squared. So we think what squared equals 25? Well, 5. So that means that our distance between 0 and the complex number is 5. So the absolute value of a complex number is its distance from 0. So here's the definition. The absolute value of a plus bi is equal to the square root of a squared plus b squared. And we got this formula using the Pythagorean theorem that I showed you in the last example. So let's try an example. Let's say we want to find the absolute value of 5 minus I. So remember, we're finding the distance from 0. So remember, we are going to use this definition. The absolute value of a complex number is equal to the square root of a squared plus b squared. Okay, so a is 5, and b is -1. So I'll plug in. So I've got square root of 5 squared plus -1 squared. Well, 5 squared is 25 and -1 squared is 1, leaving me the answer, the square root of 26, which does not simplify. So that becomes my final answer. Another one. Let's find the absolute value of 5i. So according to our definition, our a value is 0 right now. So we get the square root of 0 squared plus our b value is 5, so plus 5 squared. So 0 squared plus 5 squared is 25, and the square root of 25 is 5, which means the distance between 0 and 5i is 5. All right, let's do the the absolute value of -15. So again, we're looking for the distance between 0 and -15. So if we are looking here, we have the square root of -15 squared plus 0 squared. So, there's a typo here, because if we are doing the -15 squared, that gives us 225, and the square root of 225 is 15. So our final answer should actually be 15. Okay, I'm going to let you try to do this. So remember, do the square root of a squared plus b squared, where a is going to be -7 and b is going to be -8. Remember, when you square a negative, it becomes positive. All right, so you should have gotten the square root of -7 squared plus -8 squared. -7 squared is 49, and -8 squared is 64. 49 plus 64 is 113. So you should have gotten the square root of 113, which doesn't simplify, so you should have gotten answer number 3. So remember, to find the absolute value, or the distance from this complex number to 0, you are going to do the square root of a squared plus b squared. A should be 2 and b should be 1. So you should have the square root of 2 squared plus 1 squared, which would be 4 plus 1, which would be 5. So you should get the square root of 5, which is option number 1. Okay, one more try for you. Go ahead and do 6 minus 2i. So your a value is 6 and your b value is -2. So you should be doing the square root of 6 squared plus -2 squared. So 6 squared is 36 and -2 squared is 4. So that gives you the square root of 40. Now the square root of 40, if you do the square root of it, it's going to give you a decimal. However, you can simplify it, because 40 is the same as saying 4 times 10. And the square root of 4 is 2. So you should have gotten 2 square roots of 10, which is option number 3.